2, 1. Okay, welcome to Unit 1, Lesson 2. We are applications of prime numbers. So with our prime factors, we want to prime factorize either number. So what we're going to do, there's two ways again, division table or tree diagram. So I'm going to do one as a tree diagram and one as a division table. So I'm going to do 72 as a division table. Divides by 2 to become 36. Divides by 2 to become 18. Divides by 2 to become 9. Divides by 3 to become 3. And then 3 divides by 3 to get our 1. You always have to reduce it down to a 1 in the division table. Now, where are my prime numbers located?
On the side.
On the side. Which side? Left, right?
Left.
Left. Good. So my prime numbers are now located right here. So I would say 72. My product of prime numbers is 2 times 2 times 2 times 3 times 3. Or I could write it as 2 cubed times 3 squared. Okay, the little exponent tells you how many of the factor numbers you have. Now we're going to do 48. 48, we're going to do it as a tree diagram. So we draw two spokes, and we start with the smallest number again. It's an even number, so we're going to divide by 2. We're going to get 24. We're going to divide 24 by 2, and we're going to get 12. We're going to divide 12 by 2. Even numbers, we can always divide down to 2. And then I get a 6, another even number, dividing by 2, and then I get a 3. 3 can no longer reduce. Once you get all of your prime numbers, you are finished. So now my number 48 as a product of prime numbers becomes 2 times 2 times 2 times 2 times 3. Whoops. Or 2 to the 4th times 3. Okay, whichever way you want to write it, whichever makes sense. Now we're going to talk about the greatest common factor. The greatest common factor in a list of a set of whole numbers is the largest whole number, which divides evenly into each set of numbers. So it divides evenly, meaning you do not receive a decimal as an answer. Okay? So, for example, the GCF of 8, 16, and 20, what would our GCF be? Well, the first way to be able to figure that out is to do a factor chart. So if I were to do a factor chart of each number, I would have 8, do my factor T chart, 16, a factor T chart, and 20, a factor T chart. Now, when we start with our factor T charts, we always start with 1 times the digit. So I've got 1 times 8, 2 times 4. 16, I get 1 times 16, 2 times 8, 4 times 4. And on a 20, I have got 1 times 20, 2 times 10, we are glitching out a bit, 4 times 5. Now we look at the numbers in each set, and we look for the identical number that is the largest. So we're going to notice that we've got a couple numbers that they have the same. So we can notice every number always divides by 1. So you're not looking for the digit 1, you're looking for any number larger than a 1. Well, we also notice they all divide by 2, but they also all divide by 4. So the largest common factor is the largest number in those lists would be 4. Now we're going to take a look at the greatest common factor between 15, 25, and 35. When we talk about digits that end in 5, what are they typically divisible by? 5, exactly. So what we would do is we would divide all those by 5, and if we did a factor T chart, we would notice 5 is the only number they divide by. So this guy, his answer would be 5. 18 and 20. Again, with 18 and 20, we can get a couple possibilities here, but we're only going to get the numbers 1 and 2. Now, we've got the number 20 listed above. I'm going to put the number 18 beside it. And if I do my T-chart now, I've got 1 and 18, 2 and 9, 3 and 6. If I'm comparing these two numbers, 20 and 18, the largest number... Oh, it froze on you? Hang on. Okay, taking a look at these two numbers that we just discovered, the only numbers those ones have in common are the number 2. So it's got a number 2 in common with the 20. No other digit other than a 1 is in common, so the only GCF they have there is a 2. Now we're going to take a look at the numbers 36 and 54. So 36, we are going to make a T-chart. And same with 54. Yes? Okay. Okay, 36 is going to be 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. 54, 1 times 54, 2 times 27, 3. What does 3 go in?
17.
Is it? Let's check. 18, really close. Okay, 54 divides by 6 and 9. So if we take a look at both those lists, which two numbers do they have in common? Well, they've got 6 in common, they've got 9 in common, they've got 18 in common. Is there anything bigger than 18? No, 18 is the largest. So 18 they've got in the lists. So 18 is the GCF there. Okay. Now let's take a move up. It says, in the examples above, part A and B were fairly simple, but C was a little more complicated because it had larger numbers. In those types of cases, we like to use our prime factorization because when we prime factorize things, all we've got to do is take the product of the prime factors, and that's of the ones that match. Okay, so the product of the prime factors that match, and we would get our biggest answer here. So if I wanted the number 48 and 72, and I wanted my 2 times 2 times 3, I'm going to get 24, because 2 times 2 times 2 gives me 8. 8 times 3 is 24. So how could I come up with that? If I looked at the top, let's go back to the top. Now, where would I get my 2 times 2 times 2 times 3? Where did you notice they pulled out? They pulled out 3 2s and only 1 3. Why would they have chosen that? These guys here have 3 2s. These ones have 4. How many did they use? 3. They used the least amount. So whenever you match them up, they're going to take the least amount, and that's what they're going to use for each digit. So, for example, on this one, I'm going to write 48 right here, and I'm going to write 72 right here. So 48 is 2 times 2 times 2 times 2 times 3. 72 is 2 times 2 times 2, and then 3 times 3. So now what you do is you find out how many match in each row. So I've got 3 here and 3 here match. I use them. Here I've got a 3 and a 3 that match. I use them. The ones that don't match, you don't use. You discard. Those are considered the ones that are not necessary for your greatest common factor. That's how they got 3 2s and 1 3. So we're going to do the exact same thing for the number 90 and the number 225. So the number 90, I'm going to use factor charts, a division table. So for 90, 90 divides by 2 and gives me 45. 45 is an odd number. It is going to divide by 5. It ends in a 5, and I'm going to get a 9. 9 is going to divide by 3, and I get a 3 and a 1. So now my prime numbers for 90 are smallest to biggest, 2 times 3 times 3 times 5. I'm going to do the same thing for the number 225 and get my list, and then I'm going to match up the ones from each row. So 225, it ends in a 5, so I'm going to divide it by 5, and that gives me a 45. And we just saw 45 divides by 5, gives us a 9, divides by 3, leaves us a 3, divides by 3 and leaves us a 1. So now, smallest to biggest, I get a 3 times 3 times 5 times 5. Now we're going to locate the ones they have in common, the identical numbers in common. Now, if you'd like to loop them, you can loop them if you like. So you might go, okay, well, I've got 3's there, 3's there, and 5's there. So my greatest common factor is going to be a 3 times 3 times 5, which is 45. Okay, and we're going to do the exact same thing for the number 154 and 198. Only this time I'm going to be using the tree diagram to break them down. So 154 is an even number. It'll divide by 2, and it's going to give us a 77. Double-digit numbers always divide by itself and 11. So 7 and 11 both are prime. They're done. Now we're going to go to 198. 198. Same idea. Divide by 2. And what am I going to get when I divide by 2? I'm going to get a 99. And then, again, 9 times 11. We have double digits. Whoa. It's glitching out here a little bit. Okay, 9 times 11. 11 doesn't break down, but 9 will into 3 and 3. So now we're going to write down the factors left to right. 154 gives us 2 times 7 times 11. 198 gave us 2 times 3 times 3 times 11. The digits they have in common, 2 and 11. So its greatest common factor will be 22. 2 times 11, which will give us 22. Okay? Turn your page, folks.